And here we go. Oh, hey, loaded up a little bit faster that time. On to question 31, part, the second part of the part one. Which notation represents hydrogen isotopes? Okay, so I know that the protons cannot change with hydrogen. And I know that hydrogen has one proton. So in order for it to be an isotope, both these bottom numbers need to be one. So that can't be there. And that can't be there. And that can't be there. So you see that right off the bat, I know that the atomic number is the bottom number. And for hydrogen, it's always one. By definition of an isotope, it has different masses because it has a different number of neutrons. So the only choice for that is number one. Okay, I hope that one was easy. Naturally occurring gallium is a mixture of isotopes containing 60% of gallium-69, which is really 68.93, and 39% is gallium-71, which is really almost 71. Which numerical setup can be used to determine the mass? So numerical setup is specifically that. Just how do I set the numbers up in the equation? So I know what I need to do is I need to take this decimal, I need to move it over 2 times to make it a decimal to make it 0.6011, and I'm going to multiply that times this mass. And then the next step is I'm going to take this decimal and I'm going to move it over 2 spots. And I'm going to make this 0.3989 because I have to get rid of that 100. Whenever I do decimals, it's always part divided by whole times 100. In order for me to use that as a actual mathematical tool, I need to get it back into the decimal form. Now I'm going to do this 0.39 divided or times this number here. Okay, so I need to make sure these guys jive. So I need a 0.601 times a 68. And I don't have that here. And I do have that here. But they're dividing, and that's not going to work because I want to take these two numbers and add them together. So that's not it. Okay, so in this case, I have 2 more choosing. At least now I have both of these have the plus in the middle that I need. So these 2 could both be it. But in this case, I need a 0.601 times the 68. And I got that here, 0.601 times the 68. And then on the other piece, I need the 0.39, which is here, times the 702. This is the actual right answer. This one, I got the numbers switched up and not taken the decimal move. So the 60 should actually be over on this side, and the 39 should be with this number, and they're not decimal form, so that one doesn't work. Okay. Whew. Which list of symbols is nonmetals only? Nonmetals are to the left. Nope, I misspoke. To the right of the staircase. So I'm looking for aluminum is definitely a metal. He is right on the staircase, and he was the one, remember, on the staircase is metalloids except for aluminum. We all know aluminum is metal. We've dealt with aluminum cans. Magnesium is in group 2, and sodium is in group 1, so those are all metals. That leaves me with argon, which if I didn't know is a nonmetal, is a noble gas, and they are all nonmetals. All right, which chemical formula represents lead-4 oxide? So here is a crisscross method is what we use here. So I know that the charge on lead-4 is 4 because, say it with me again, the Roman numeral is the charge. I know you've heard that. So I know that the charge on lead automatically is 4. Oxide is oxygen. I name it by losing the end of it and adding it "ide," and oxygen is always a -2. And what I do is I crisscross. The 2 is going to come down to the lead. The 4 is going to come down to the oxygen, and I'm going to be able to rewrite this Pb with a 4. I'm leaving out, I left out the Pb, so let me get the B in there. So what happens when I'm writing with my mouse? Pb4, and nope, it's Pb2, get rid of this. Pb2. Silly Noakes making mistakes. You don't like that, Mr. Noakes. Pb. The 2 goes to the Pb, and then the O goes to the 4. And do I see this as a choice? No, and that's a good thing that I don't see this as a choice. You should be thankful because what I can do now is reduce. This 2 now becomes a 1, and this 4 becomes a 2. So this is PbO2. And I do see PbO2. So I got really lucky in this case that they didn't give me Pb2O4 and I'd have to know to reduce. Okay. It's very nice of them. I think that's very fair when they do that. All right, which statement describes the general trends in electronegativity and atomic radius? From left to right, period 2. I don't have any choice but to look this up. And I remember during the test for atoms and bonding back in the day, I told you to please just look this up. We did electronegativity difference. So it says in period 2, so I find period 2, that's lithium, beryllium, boron, carbon, nitrogen, all the way across. So let me pick 2. I'm going to pick beryllium 4 and nitrogen 7. 4 and 7. And I'm going to go to table S and compare just 4 and 7. So 4 has an electronegativity of 1.6 and 7 has a 3.0. So my electronegativity is going up. Okay, so I want to find one that says electronegativity is going up. So both electronegativity and atomic radius are going down. Don't want that. Electronegativity increases. I like that. Electronegativity decreases. I don't like that because I know electronegativity has to increase. And now atomic radius 4. I get 99 for beryllium. I get 71 for nitrogen. So my atomic radius is actually going down. So which one of these has my atomic radius going down? Number 3. And I just worked my way through that problem using table S and pick 2 elements, and we're ready to go. All right. What is the percent composition by mass of nitrogen in this beast? And it gives me the GFM, so I don't have to calculate it. So what I need to know is between this 2 replies to the ammonium. That means there's 2 nitrogens. Nitrogen's mass, when I look it up, is 14. So 2 nitrogens is 18. So I have a total mass of 18 for nitrogen over 96. 18 divided by 96 times 100 is my mathematical operation. So let me get out my handy dandy calculator. On the Regents exam, you'll be using a real calculator, not your phone. I'm stuck in the greenhouse. So, I got 18.75 multiplied by 100. What is the percent by mass of the nitrogen in? I got 18.75. Nitrogen is 14. Do I have the mass of nitrogen wrong? What's going on here? Periodic table. By nitrogen. Off the top of my head, I thought it was 14. It is 14. Oh, 14 and 14 is not 18. Oops. 14 and 14 is 28. So there. Just model for you how we can have what we do when we see that the answer that we want to see is not there. So now I decide 28 divided by 96. Now I get 29.16. So 29.2 will count. And there we go. I'm glad I didn't just say, oh, this number's closest. I went back and figured out what I did wrong. Okay. Given the balanced equation, which type of chemical reactions does this equation represent? I got a Ki with an F and then Kf with an I. This is one thing switching out, not 2 things. So this is a single replacement reaction. By definition, one thing, right? Synthesis is to make, so take 2 things and to make one big thing. Decomposition is to break apart, take one thing and break it into 2. And then we have the double replacement, which is the double switch, where I have 2 compounds. Single replacement is when I have a compound and just a lone element, so I only have the one switcheroo. Which molecule represents a nonpolar molecule containing polar covalent bonds? Okay, nonpolar molecule. Well, ammonium is the same this way, but ammonium is not the same this way, so it's very polar. We know that water is also very polar because it's not the same top and bottom. So polar, that's out. So these are my 2 nonpolar molecules. But now I need polar covalent bonds. And that means my electronegativity difference has got to be greater than 0.4, but less than 1.7. So when I look at the electronegativity of hydrogen, when I look it up and it was 2.2 minus 2.2, that's a 0. So here is where I have a polar covalent bond between the O and the C. But remember, they both cancel out because one's going in this direction. Remember this little symbol, that dipole? And one's going in this direction. And they cancel each other out. So they make a nonpolar molecule, even though they are covalent bonds. And that'll be it for this segment. See you guys next video.